right, so our last unit we're going to take a look at for this year is on exponents. Okay, so we're going to start out just by looking at some basic rules for exponents. Okay, and those things we were looking at in the warm-up when we multiplied something like x squared times x cubed, x to the negative third times x to the fifth, 7 squared times 7 to the fourth, all that stuff, those are all called monomials. Okay, every one of those things I just said to you, the fancy name for them, is not numbers with exponents, but they're called monomials. Right? And we looked at in the warm-up different ways we can break up or combine things with exponents. You saw something like this in the warm-up, with the parentheses. When I have 3 to the 6th power, basically what that means is to multiply 3 by itself 6 times. You can do it any way you want. You can group 2 of them together and then 4 of them. So 3 squared, 3 to the 4th. But the important thing is if you look at the 2 and the 4 and you add them, what number do you get? 6. Let's say you group it as a group of 3 and another group of 3. 3 to the 3rd, 3 to the 3rd. What do you get if you add 3 and 3? 6. Let's say you group it as a group of 5 and a group of 1. If you add 5 and 1, what do you get? 6.
So it can't be any higher than 6.
Right, that's the point. No matter how you group it, the number of 3's that you write down has to come out to 6. Okay, and this is important because it gives us an idea of what one of our first rules is going to be. Okay? If you look at your exponents, when you add them up, it's going to have to do with that exponent that you were given. 2 plus 4, 6. 5 plus 1, 6. All right, so we're gonna see that come up in a little bit. All right, so I said earlier those terms I was giving you, they're called monomials. Okay, well, this is the definition of a monomial. Okay, so a monomial, it can be a constant. Okay, constant means number. Right, so a monomial can be a number. It can be a variable. What's a variable? That's a...
Like a letter.
Yeah, it's a letter. Or it can be a product. What does product mean? What operation is product?
Multiply.
Yep. Multiply. Right? Multiply a constant and a variable. Okay? So you can multiply a number and a letter together, and that's also called a monomial. Right? So let's look at some examples and see if these are considered monomials or not monomials. Right? All right, let's look at this first one. Right? -7. Let's read the definition and see if that fits. Is -7 a number? Yes. So then -7 is a monomial. Okay, it's a number. All right. Let's look at x. Do you think x is a monomial? Yep, it's a variable. And does it say in the definition that a variable can be a monomial? Yes. A monomial can be a number, a letter. Okay, in this case, it's a letter. All right, let's look at the next one. 4 times x cubed. Okay. What's 4? A number. What's x cubed? That's a variable. And we're multiplying the two together. It says a monomial can be the product of a number and a letter. So 4x cubed, that is a monomial. Okay? Those are all examples of monomials. Okay? How about if I did 2xy? Yeah. Does it say I can have more than one variable? Yeah. One or more variables. Okay? As long as you're multiplying, you can multiply as many things as you want. That's still a monomial. That's just one giant monomial. What makes something not a monomial is if you do this. Okay, if you put x plus y. Okay, what do you think I wrote down right there that makes it not a monomial?
The plus.
Yeah, the plus. Okay, anytime you put a plus sign, a minus sign, all of a sudden you don't have a monomial anymore. Okay? So I'll just put that. You cannot have plus or minus signs. If you put plus and minus signs, that still is called something. Okay? But it's no longer mono. Okay? Mono means one by itself. All right? If you put a plus sign in, how many things do you have now? You have two, okay? And that's called a binomial. Okay? We're not going to talk about a binomial today, but if you put a plus or a minus sign in, now you no longer have monomial. You don't have one, you have two. Okay? All right, so let's go through a couple more examples together, because what you might see on the test is a true-false question. Is this a monomial? Just true or false. What if I said 5? Is 5 a monomial? Yes. It's just a single number. How about y? Yes. A single letter is a monomial. How about 4y? Yes. Y. What's 4y? It means what operation? Multiply. Yep. How about if I said negative 2x cubed? Is that a monomial? Negative 2x cubed. Yes. What are you looking for to make it not a monomial? Minus or a plus sign. Okay? In terms of what we're doing, that's all you have to look for. If it doesn't have a minus or a plus sign, it's a monomial. Does anybody remember what I said if it has a plus sign and you had two of them? Yeah, that's a binomial. Anybody have a guess? We're not going to get to this for quite a while. Now I have 3 parts. Anybody have a guess what that would be? That's a trinomial. Okay, tri because it means 3. All right, so we're going to look at the names of the parts when you set up what's called a monomial with an exponent. Okay, the base is the number that's always down low. So in my examples, x is a base, x again is a base. Okay, the exponent is always the number that we put higher. Okay, for now it'll be a number, but eventually when we get into the graphing ones that I showed you guys, okay, like that one in blue or that one in red, we're going to see things where the exponent is actually a letter, okay, like 2 to the x power.
But guys, for the sake of what we do today, tomorrow, Wednesday, all right, it'll all be numbers. So the small number is the exponent, the big number or letter, that's the base.
All right, so when we did the warm-up, okay, we looked at combining monomials. If you noticed, all the problems that we did had to have the same base. Okay, if we go back and we just look at them, what's the base in everything in this problem? X. How about the one below it? X. How about the ones on the left? The base is all 7s. How about example A? What was the base? 3. Example B? 2. Okay, the base has to be the same all the way through. Okay, you can't do something like this times something like this and simplify it. Okay? The reason? Different bases. Okay, so we've got to stick with the same base. Do those have the same base? a cubed and a to the fourth?
Yes.
Yeah, they have the same base. But they have different what?
Exponents.
Different exponents. Good. Okay, same base, different exponents. Right, so I think from the warm-up, you guys already know.
Wait, can you go back up for a second?
Yep.
Hey guys, all you really need to write down right now is, as long as you filled in the little diagram, and then it says anything to multiply or divide monomials, you're just gonna put bases have to be the same. We haven't got to that next thing to multiply powers.
All right, so we're going to try to look at a pattern. Okay, I think most of you already see the pattern, but let's just do this one out, see where the pattern comes from. Sam, how do you pronounce this first part of the monomial? Perfect, a to the third power. And Gage, can you tell me, what does that mean, a to the third power? Hold on, you guys. What did you say, Gage? Yep, you said it perfect. It means a times a times a. All right, Davin, can you pronounce that second part for me? The second part of that monomial? Okay, that's what it means, but how do you pronounce this? A to the fourth. Yep. And it means a times a times a times a. So now, Corey, if we were to multiply that out, we have a times a times a times a times a times a times a. How many a's do we have? How many? 7. So, if we were to end up simplifying it, that's what you'd get. Okay? And the reason? You have 7 a's. So you might notice a shortcut. Look at the 4 and the 3.
Yeah, do we have to completely write out all of those A's?
Nope, we're going to learn a shortcut.
We could just do 4
Wait,
plus
are we
3
writing
would
that
be
down?
like
Yeah, so we're going to learn that that's what the shortcut is. Okay? After we do it out the long way and see the pattern, now we're just going to use the shortcut. Okay, let's.
Are we writing that down?
It's up to you. If you know how to do it, that's fine.
We'll do a bunch of examples like that too.
If you feel you need it, go ahead.
The words.
No, you don't have to write all that down. No, when we get to the next page, we're gonna even simplify that even more.
All right, what's y cubed mean?
a to the 6th power.
Y what?
Y to the 6th power.
Yeah. The first one means you have y times y times how many more? Times 3 more. Y times y times y. And now if you look at how many y's you have, how many? 6. So how do you think we would write that one? Y to the 6th.
So that was like the plus.
Yeah, that's where you add your exponents. And it takes a while to write it out, but if you had something like this, I'm just making something up, something kind of complicated, and you forget, you know what, I don't remember my rules for negative exponents, I'm dividing, I'm multiplying, I don't remember everything, you can always write it out the long way and figure it out, okay? Even if you forget all the rules for multiplying monomials, you can always write it out the long way. Little tricky. What's not written here, but you have to know it's there? A 1 where?
In front of the X.
And what is that 1? It's my... Because you mean the 1 right in front of it, the coefficient?
Yeah.
Okay, that's true. There is a 1 there.
Oh, he's right.
But I'm not talking about the coefficient. What do you think I'm thinking of? The exponent, yeah. There's a 1 as an exponent. So what do you think x to the first times x to the fourth is going to be? X to the
Oh, 50.
fifth. Right? So we can't forget about that other 1 there. Right? So if you don't see an exponent written, you could always fill in a 1. All right? And that's, if you don't know that, that's important. Just like Victor said, you can put a 1 in front for your coefficient. You can also put a 1 as an exponent if it's not there. Right, so here's kind of the summary of what we just did. This rule is called a product, because you're multiplying. And you're multiplying together your powers. It's a product of 2 powers.
And guys, underneath this, when we get to that next step, we're going to kind of take this rule and kind of simplify it a little bit into what we can understand.
Right, so product of
So
powers.
I'm not writing this down anyways, Mr. Hager.
Who could explain that to me? What is that rules basically telling me to do? Look at that equation.
Think of it, in your answer, guys, you should use the word exponents, and you should use the word base, or bases.
So correct the power source.
No, you don't have to put that down, Victor, no. We're trying to figure out what that means right now. And then once Mr. Hager scrolls down, we'll have it written down. But what are you really doing with those exponents when they have the same base? Yeah, we're adding them, right? So what could we say for our rule? How can we simplify that into terms we can understand a little bit better? So you already have the start off, it says to multiply powers. How would you fill the rest of that in? What do they have that's the same? Yeah, so to multiply powers, keep going, with the same base, add the exponents. Perfect. So there it is right there. To multiply powers with the same base, you add exponents and keep the base the same. Right? And some people make that mistake even when you have a number as a base. Right? Sometimes they want to say, okay, I got 8 and 8 as the base, and 3 and 2 as the exponents. I want to multiply 8 and 8. No, keep the base the same. Keep it as 8. So basically, when you're multiplying exponents, you're really adding them.
And all the rules that we learn for exponents are very straightforward. What gets tricky is when to use which rule, okay? Especially when we have every rule in the same problem. Okay, so you're not going to learn any arithmetic here that's hard. Just you have to know what rule to use when. Okay, does everybody have that? Okay, so to multiply powers with the same base, add the exponents. Keep the base the same. All right, so we'll take a look at a couple examples.
You guys, on your sheet, you don't have the examples. I don't want you guys to go ahead. You don't have the examples written. You have to write them down.
Okay, and as a hint there, we talked about. So anyone think they can tell me what r to the 7th times r is? Yep.
R to the 7th. No, wait, R to the 6th.
Okay, how'd you get that?
Because you like, that would be 8. If you add 7 and 1, it's 8, right?
If you add 7 and 1, you get 8. Now, why are you doing 7 plus 1?
Because you're multiplying. So you add 7.
I'm confused about the 1. Can somebody explain that to me? I have no idea where that's. I don't see that written down in the problem.
The r by itself doesn't have an exponent, so you add in 1.
Perfect. Okay. R by itself doesn't have an exponent, so we put a 1. Okay, now I understand where the 1's coming from. And now I can see why Rose did R plus 7 plus 1, because you add exponents. And Rose, what did you say it is?
R to the 8th.
Perfect. Okay, R to the 8th. All right, C squared times D squared. Okay, what do I do here? Any thoughts? Can somebody read back the rule to me that we just wrote out? Victor, can you read that rule to me?
The multiplied power.
Yeah, that one.
It says with the same base, add the exponents.
Okay, to multiply powers with the same base, add the exponents. So what's the condition in that rule? What does it say you have to have to
Same base.
same base? Yep.
So they have the same base R.
For 1B, Victor.
Oh, snap. Okay. Oh, wait. Yeah, they're different.
They're different what? Different exponents or different bases?
Different bases.
Yeah, the bases are different. So that rule that we just learned doesn't even work, doesn't apply. So in this problem, you can't do anything. Right? So this can't be simplified. If I asked you to simplify this on the test, you just write down the same thing again. Can't be simplified. Or you could say just you cannot simplify it. Right, how about one like, let's try x to the 4th times x to the 6th.
So that'd be no, wait.
X to the 10th.
Yep, that'd be x to the
The
10th.
base, keep the big thing, add the small things.
Now, why can we do example 1c, but we couldn't do 1b? Yeah, here the bases are the same. Perfect. How about a squared times a cubed?
Would it be
A to the 5th power.
Yep, a to the 5th. Okay, how about m to the 4th times m to the 12th?
M to the 16th power.
M to the 16th power.
Guys, I don't think you have space for 1F, which is okay.
Try this one.
Would that still be can't be
Yeah, guys, so you've got some room on the right-hand side there. If you want to just add a space from 1F, all right, you can do that.
would that still be considered can't be simplified?
Well,
It can
the
be-
question I ask myself is, do I see the same base written more than once in the problem?
Yeah.
If you see the same base more than once, then yes, you can simplify it. Right? You can't simplify bases that are x's with bases that are y's. My final answer is still going to have a base of x in
Oh,
it.
so it'd be x and 7, I meant
Yep, x to the 8th.
8, times y 11.
Yes.
I was thinking like x comma x to the 8th power comma y.
Yep, Victor said it perfect when he said
Times.
times.
Guys,
Yep.
you can almost think of it like combining like terms. You have your x's, keep the x, add the numbers, or the exponents. You have your y's, keep that base, add the two exponents together.
Let me show you guys one more. X cubed times y to the first times x to the second times y to the fourth. What's a little different about this one?
The y's aren't together, the x's are together.
Yeah, the x's aren't together, the y's aren't together. That doesn't matter. This is exactly the same type as the last problem. You can still combine the x's with the x's.
X to the fifth times
So x to the fifth, yeah,
times y to the fifth.
times y to the fifth. Good.
You guys, if you write your answer without the little multiplication dot, that's okay. You can write x to the fifth, y to the fifth.
Right. Any questions on that? And you can do this with as many letters as you want. Your final answer, though, you should only see the base of x one time, the base of y one time.
So, Ariana, Dietz, what's the rule again for multiplying exponents? Base is going to be the same. If they're the same, then what? Add the exponents. What happens to the base in your answer? Stays the same. Good. Perfect.
All right, so those last two examples, we were kind of giving you a preview of what's going to come up right now.
Yeah.
Okay? What you guys just did, even though you didn't really write it down, you did it in your head, is you used the commutative property. You basically took the x's, put those next to each other. You took the y's, and you put those next to each other. Okay? So we changed the order, and then we combined our like terms. Right? We're going to do the same kind of thing again. We're just going to practice with some more letters, and we might even throw some numbers in there too. All right? So all you want to think about is grouping together things that are the same. All right? So let's try this one.
Guys, you don't have this on your thing. All right, let's just do it. Let's do this one together so you guys can see it, and then then you guys can write it 2B. So this one's not on your sheet. There's not a space for it.
Somebody tell me something that I can combine with something here. Yep.
Do something with the d.
Yep, you can combine this d with what?
D to the third power.
With the d to the third.
Would it make it d to the fourth?
Yes. Yep. It would become d to the fourth. I'll write that down in 1 second. Can somebody tell me something else I can combine? Okay, we've got the d's. What, Maria? Yep. I can combine the c with the c. Again, don't worry about the answer. We'll do it in a second. One more thing I can combine.
You have to add one exponent on.
What's the last thing I can combine here? Yep, the numbers. We've got -3, and we've got 7. Okay, let's start with that. That's the easiest one. Okay, this is all multiplication. So we've got -3 times 7. Okay, I could have done that in my head, but I'm just going to write it like that for now. Next, okay, we're going to combine the c's. We have a c squared, and we have a c. Yeah, if you want to put into the first, you can. And we have a d to the first. And what else? D to the third power. Okay. So all I did from the step above to the step below was kind of put everything next to each other that we're going to combine. What's -3 times 7, Alex? -21. -21 c to the, about right? It's going to be my exponent on c. Well, look back at what's the exponent on the original? Yeah, 2 plus 1 gives me 3. Okay. And I think Gage already told us our exponent on d was d to the fourth. Right, so if we see a problem and we don't need to rewrite it, we can just see, oh, we're going to combine the x's, we're going to combine the y's, we're going to combine the z's. We can do that part in our head. If we need to rewrite it, we can rewrite it.
Guys, I'll let Mr. Hager do one more. Then I do a little bit. I have another way that I do it. I mean, I do it the same way, just in terms of breaking it down, so you don't have to write everything out. I'll show you guys that in a second.
Okay, what do I have to combine here? Somebody tell me.
So guys, just so you know, you do have a spot for 2B on your sheet.
What are we going to combine here? Yeah? Okay. Don't even worry what it is yet. We're going to combine the x's. I like it. What else are we going to combine?
The -5 and the 2.
I like the idea of combining the -5 with something.
But there's nothing to.
Yeah.
What do we combine it with?
Nothing?
There's something there.
There's
Z would be the x because there's a 1 weight on it.
Yeah, where'd you get -1 from?
Oh,
Right there.
because
Okay.
there's like a 1. Yeah.
Even though there's no negative in front, there's no 1 in front, you have to fill that in. Right, so now let's just combine them again. What's -5 times -1? Sabrina? 5. Okay. Somebody said combine my x's. What's x squared times x? How about Ryan?
3.
So what do I put right here?
X3.
X to the 3rd. Yeah. Now, what about the y and the z cubed?
Do you just put like y and then z?
Yeah. Just
I
put
mean z.
y and z cubed. If you can't combine the y with anything, and you can't combine z cubed with anything, just leave it the way it is. If there's nothing to combine it, you still have to write it down in the final answer. It's just there was nothing to combine it with. Okay. Check your final answer. Do you see x written more than one time? Oh, Ariana? Do you see x written more than once? No. How about y? No. And z? No. Each letter should only be written one time when you're done. If you had a final answer like this, you forgot something. Okay? You shouldn't see the same letter written twice. All right. Do you guys, how many, we got a lot of, yeah, we got a ton of these. I don't think we need to do them all.
Can you go back up for a second?
Yeah, I'll let you guys pick one of them. Okay, how about, you want to do 2C, 2D, or 2E?
Can we do
2C?
So you mind if I do this one?
Yeah.
All right, guys, like Mr. Hager was doing on those last couple of, I'm sure tonight when you're at home or if you work on it in another class, your homework, you're not going to have like 3 or 4 different colored like pencils or markers. So what I do is when I do these, I separate the numbers from the different letters. Remember we said before, like there's no sign here, right? There's no sign with that 3, but we know that it's what? Positive, right? And we said if there's like if there's a negative sign, right? The sign goes with the, remember the sign to the left goes with the number, like this negative sign goes with the 2, right? We talked about that this year. When we're doing this kind of stuff, the exponent to the right belongs to that base, all right? So like the 5 belongs to that A, the 4 belongs to that B, all right? So what I do when I do these is I separate the numbers from the bases and the variables. So like I separate it with a line. I make sure I draw my line, make sure it's long enough So I know that it's not a 1. So that's separated. The a to the 5th is separate, the b to the 4th is separate, and the c is separate. Inside the parentheses, the -2 is separate, the b to the 3rd is separate, and the c to the 8th is separate. All right? So what's the first pair that I can multiply? Someone tell me by raising their hand. What's the first pair that I can multiply? What's a like that I can multiply? Alex?
The 3 and the negative.
The 3 and the -2, just the regular big numbers, right? The 3 and the -2. What do you get, Alex?
-6.
-6. So that's one thing. Sometimes what I do, you don't have to. Sometimes I just check off. Yeah, I use that. I use that. They're done. All right. Now, if I was going to go in alphabetical order, right, from the letter that comes first in the alphabet to the letter that comes last, what's the first letter that I have in that problem? If I was going in alphabetical order, what's the first letter that shows up? A shows up. So I look at A here, Logan. Is there an A in the other thing? Nothing, right? So
You just put A to the.
just put A to the 5th, right? There's nothing else like it. So I'll put A to the 5th because there's nothing else like it. That's done. All right.
Can you do the B's next, or
We can do the B's next, Rosie. What do you get?
you get B to the 7?
Nice. Put my B, right? Keep my base, which is B. Add my exponents. Gives me 7. Right? B to the 4th, B to the 3rd. How about Alexis? How about what's left? And what should be part of my answer? All right. Are you saying that you want to add the 1? You want to put a little 1 here? Is that what you're saying? Okay. I'll put a 1 there. If you know that there's a 1 there, that's fine. If you want to write it in, that's fine too. You're not wrong either way. So I know part of my answer is going to be what letter? C. All right. And what needs to be with it, Alexis? C to the what? 9th. Bang. Like Mr. Hager said, I have no variables that are the same. All right. I'm in good shape. So if you want to do it that way, that's fine too. You want to draw lines in there to separate them, you can do that too. All right?
Yeah, why don't you try the next one? If we have time, we can come back and do another one of those, but there's one last type I just want to make sure we get to. I want to do 3.
Those ones that come last, I didn't put anything like that on the homework. Because I don't think we tested them on that last year. Let's try.
Mr. Wade, can we do one though first and then come back to those?
You want to do one of the other ones?
Yeah.
Okay, that's fine. Guys, we just want to show you, why don't you do me a favor on your notes? We just did 2C, right? The spot for 2D, can you do me a favor and just kind of scratch that out and put 3A?
Wait, what block is it?
Instead of 2D, scratch it out and put 3A. Guys, you're not really going to be responsible for this on the test. All right, we're not going to ask you to do anything like this on the test, but it's just good to know how those exponents work. It's good to know how the exponents work with some numbers there. So like what we did on homework. All right, so I see this word right here. I'll let you guys get it written down first before I start asking questions. So, I got that word up there underlined that says evaluate. We talked about that a little bit. We talked about that quite a bit at the beginning of the year. Not so much recently. Victor, what's that word mean? I called on you because we were talking. What's that word mean, evaluate? Okay, what do you think?
Another name.
Come on, Corey, to help you out. What do you got, Corey?
The only thing that was say that someone's on PTO, like at a tryout.
Okay.
They're watching it and they see.
All right. Okay.
It's something you're going to do after you simplify. We're
Yeah.
gonna simplify first and then evaluate. So do you notice anything extra on the board
So
there?
like we just like checking it.
Look, Victor, look what we're giving you here.
Add the numbers into the problem.
Exactly. We're gonna plug those numbers in. But like Mr. Hager said, let's simplify first. Like, look at the directions. Simplify and evaluate. All right? So, Chloe, when I simplify those x's, when I simplify my x's, what am I going to get? Okay, what else do I have to put? I like the 4. I'm gonna make the 4 small, Chloe. I like that. What needs to be with it? Nice job. Perfect. Remember, keep the base, keep the big guy, add the small guys. Davin, what about the y's, my friend? And you can't say I don't know. Y what? Perfect. Thank you very much, my friend. All right, x to the 4th, y to the 3. So now we've done the first part of the directions. We've simplified. What's the next step? What's it say to do next, Logan?
You have to do -3 to the 4th power.
Right.
Times -1 to
Negative 3 to the 4th power, and then y, oops, my bad. Y is -1 to the 3rd. And you want parentheses around just the numbers, right, Mr. Hager? Like this? All right. So, we're not going to talk about this too much, but is 4 odd number or an even number? Even, right? Is 3 an odd number or an even number? Huh? Odd, yeah. So 4 is even, 3 is odd. My bases, are they positive or negative? They're both negative. So there's a little rule here. If I have a negative base and an even exponent, my answer is going to be positive. If I have a negative base with an odd exponent, my answer is going to be negative. Because what does -3 to the 4th power mean? What's that mean, Kevin? -3 to the 4th power. Logan?
I think you're multiplying -3 for individuals.
Exactly. So it sort of looks like this. -3 times -3 times -3 times -3.
What happens is, doesn't it cancel out the first 2 times?
Well, but -3 and -3 is
Yeah.
what? Positive what?
9.
9. So I did that here. These guys are taken care of. And then -3 times -3 again? Positive 9. 9 times 9? 81. Positive 81. All right? Right? Everything, because it's even, everything's balanced. I can multiply these two negative guys together positive, these 2 negative guys together to get a positive. And I get my 81. Now, -1 to the 3rd power is -1 times -1 times -1. -1 times -1, positive 1 times, I still got this guy hanging out. I still got that -1 hanging out. It'll give me -1. So now I got 81 times -1.
Oh, it's gonna be -81.
It's going to equal -81.
Okay.
Now, Mr. Hager's going to show you guys on the calculator, make sure, because when I was writing these down, Mr. Hager gave me the hint to make sure I put parentheses. When you punch a negative base in with an exponent, you need to make sure you put it in parentheses. See how Mr. Hager did it up here? He put parentheses around the -3, he put parentheses around the -1. You need to make sure that you do that, or you won't get the right answer. All right? And Mr. Hager just put in, look, he put in -3 to the 4th, but he put -3 to the 4th, but he put no parentheses around it. He got the wrong answer. So if you're gonna use a calculator, does everybody know how, on the calculators that you guys have, how to put exponents? Everybody knows how to do that? What's the button look like? You can tell me.
X2 here with.
Oh, wait, are you talking about parentheses?
No, I'm not talking about parentheses, I'm talking about to do exponents. Rose?
Like a little arrow.
Yeah, it's almost like a little arrow, right? Looks like, here it is right here, sort of looks like this. Little arrow pointing up. If you put whatever base you have, like obviously you can't use letters on the calculators you guys have, but whatever number you want, hit that little button, all right? Put the exponent in you want, you'll get the answer. Maria?
Square button on there too.
That may work as well. I don't do it that way.
That only works if it's squared.
Okay. It only works if it's to the second power. Yeah. So if you want, like Maria said, if you have something to the second power, you want to use the square button, you can do that too. All right? But this little button right here will work for any number, any power. All right? So like I said, guys, we just wanted to show you one of those and how that worked. All right? Why don't we go back? And why don't you guys try right now? Why don't you try, is there a spot in your thing for 2E? All right, do me a favor. I want you to do this. I want you to do this one right now. All right, on your own. I know some people, guys. I know some people had some trouble with. Remember, if there's a negative sign, there after it, make sure you put -1. All right. So I'm gonna. If you separated it, this is how you would separate it. Here, 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 here. All right. Then I'm going to do -1 times 3, which gives me what? -3. I'm going to do C to the third, what's it give me? C to the fourth.
Oh, the -3, yo.
And then D to the second and D, what do I get? D to the second and D, what do I get? D to the third. Here's your answers. All right, guys, I just want to quickly, tonight's homework, all right. Tonight's homework, 6.1. Remember, Mr. Hager has it up on the board here. Our test, please listen, our test is going to be on Thursday. When's our test, Ryan? Thursday, right?
Friday.
Reason being, half day on Friday, and we only have half the class. We only have period 1, right? So we don't have to double block. Friday we'll do a MCAS, open response.